For this lesson, we're going to take a look at dividing fractions, and we're going to start with a really straightforward example here where we're going to just take one fraction and divide by another fraction. Remember that when you divide by fractions, you need to take the second fraction and change it to the reciprocal. Dividing by a fraction is the same as multiplying by its reciprocal. So we'd have 45 over 15, and now we're going to cancel out any common factors to simplify. 5 and 15 have a common factor of 5, and then 3 and 45 both have a common factor of 3, and then 15 and 36 both have a common factor of 3. And so if we take a look at this point in our numerator, we're just left with a 1 times 5, which is 5. And in our denominator, we're left with a 12 times 1, which is 12. Let's take a look at another example. This one's going to involve some variables. So we need to start by rewriting this question where multiplying or dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to rewrite x squared over 15 as 15 over x squared. And then I'm going to cancel any common factors. Here we have a factor of x, and here we have a factor of x squared. We can think of x squared as x times x. So this x can cancel with one of these x's. We're just going to be left with an x to the first. And 15 and 6 have a common factor of 3. So if we do 6 divided by 3, we get 2. And 15 divided by 3, we get 5. And now we've canceled out all the common factors, so I'm just going to write our final answer. We just have a 5 in the numerator, and in the denominator we'd be left with 2x times y to the third. Let's take a look at a third example. We have 6 examples that we're going to take a look at today. For our third example, we have a lot of factoring actually that we need to do here. But first of all, let's rewrite the problem. We'd have x squared plus 3x minus 10 over 2x plus 6. And to divide by a fraction is the same as multiplying by its reciprocal. So we'd have an x squared minus 4 in the denominator and an x squared minus x minus 12 in the numerator. And now I'm going to go through and I'm going to factor each of these numerators and denominators. Here I have a greatest common factor of 2. So I remove that and we would be left with x plus 3. And I'm thinking x plus 3 might be a factor here. Let's see, x plus 3 times x minus 4. I can do a quick check here. Negative 3 times negative 4 is going to give me the negative 12. X times x gives me x squared. And then if I multiply the 3 times the x, I get a 3x. And an x with a negative 4, I get a negative 4x. And negative 4x plus 3x does give me a negative x for my middle term, so that looks good. So let's get rid of all these lines here, and we'll keep going with more factoring. X squared minus 4, that's a difference of squares. We have x minus 2 times x plus 2. And factoring over here, I need factors of 10 that differ by 3. So factors of 10 that differ by 3 would be 5 and 2. And we'd have a plus 5 and a minus 2. Since I have a positive 3, I need the positive to go with my larger number. And now I'm going to cancel out any common factors that we have. We have a common factor of x plus 3. And we also have a common factor of x minus 2. So our final answer for this particular problem is x plus 5 times the quantity x minus 4 all over 2 times the quantity x plus 2. Right, let's take a look at a few more examples. Here we're going to start by rewriting this problem as a multiplication problem. We'd have 3 plus 3y over 6 times the reciprocal of 1 plus y over 9, so that'd be 9 over 1 plus y. And now I'm going to factor a 3 out of this first numerator. I'd be left with 1 plus y over 6, and here we'd have 9 over 1 plus y. Canceling out common factors, 1 plus y is a common factor. 6 and 3 have a common factor of 3. 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. And what I'm left with here in the numerator is 1 times 9, which is 9. And in my denominator, I'm left with just a 2, so we have 9 halves. The fifth example here we're going to take a look at is a little different. It looks like we're going to have quite a few things cancel out, possibly. We have things here that seem to be occurring more than once. We have 5 over c minus d, and then to divide by a fraction is the same as multiplying by its reciprocal. So we'd have d minus c over 5, and of course the 5's cancel. And d minus c over c minus d, well, those are opposites, and we know that when you take a number divided by its opposite, you get -1. So our final answer to this question is simply -1. And let's take a look at this last example. For this last example, I'm going to start by rewriting this division problem as a multiplication problem. So we have 6x minus 6y over x to the 4th minus y to the 4th. And then we have x squared plus y squared over 6. So I'm taking this second fraction and taking the reciprocal of it. Now I'm going to rewrite this removing greatest common factors or doing other factoring. Here I can remove a greatest common factor of 6 from the 6x minus 6y. And in the denominator, I recognize x to the 4th minus y to the 4th as a difference of squares. So I'm going to factor that as x squared plus y squared times the quantity x squared minus y squared. And I'm going to need to extend my division bar here a little bit. And there's really no factoring I can do on my second fraction. But now I notice that this x squared minus y squared, that's also a difference of squares, and it might be helpful to factor that as well. So let me rewrite what I have here, and I'm going to rewrite x squared minus y squared as a difference of squares, x plus y, x minus y. And if you notice here, we have an x squared plus y squared in the numerator, and we also have an x squared plus y squared in the denominator, so those will cancel. And we also have a factor of x minus y that can cancel, and we also have factors of 6 that can cancel. So we've actually canceled out all the factors in the numerator, but we're still left with a factor of 1, and in our denominator we're left with x plus y. We'll be doing more examples like this in class, and you'll be able to work together to solve some even more challenging problems.